So, what's happening this week? Uncrewed autonomous mapping under the sea. Is ConTech adoption as easy as 3 steps? AI and LiDAR are like a seatbelt, but for pedestrians and cyclists. Quite the dentalgrammetry innovation. And in 1981 AEC Error of the Week, so catastrophic, load distribution analysis was never the same. Recappers, get out! Yeah, shoo, our lead story ain't got time for humans. It's all about uncrewed autonomous seafloor mapping. But if we see further because we stood on the shoulders of giants, then for seafloor mapping, few were as consequential as Marie Tharp. Her work remains staggering both for its scientific contributions and the challenges endemic to male-dominated fields. Born in 1920, Tharp was drawn to mapping through her father's work as a soil surveyor for the U.S. Department of Agriculture. After earning degrees in English, music, geology, and mathematics, Miss Polymath over here joined Columbia University's Lamont Geological Observatory in 1948, where she began her storied collaboration with Bruce Heezen. Barred from ocean expeditions due to her gender, Tharp worked on land to analyze data collected by Heezen and his lads. Via physiographic mapping techniques, she meticulously plotted thousands of sonar readings onto charts, profiling the ocean floor's topography. She integrated data from sources like the Woods Hole Oceanographic Institution and seismic readings from underwater earthquakes to ensure accuracy. In the early 50s, Tharp made a pivotal discovery, a continuous rift valley running along the mid-Atlantic ridge. This provided crucial evidence for the theory of continental drift, which was largely dismissed at the time. Initially, even Heezen rejected her findings as, quote, girl talk, but the evidence eventually became irrefutable. Together, Tharp and Heezen published their first physiographic map of the North Atlantic Ocean in 1957, and over 3 decades they would map the entire ocean floor, culminating in the publication of the World Ocean Floor Map in 1977. With help from the General Bathymetric Chart of the World, Tharp's maps revealed a 40,000-mile underwater ridge girdling the globe and demonstrated that seafloor spreading from central ridges drives continental movement, a foundational concept for plate tectonic theory. Weeks later, however, Tharp's cherished ally Heezen died of a heart attack while exploring the mid-ocean ridge near Iceland. And with that, the sun had set on Marie's illustrious career. She retired. Despite her achievements, Tharp faced a barrage of barriers throughout her career. She was often excluded from recognition during her collaboration with Heezen. Her name did not even appear on numerous papers, but her legacy has since been celebrated. In the final decade of her life, Tharp was honored with prestigious awards from renowned institutions, including Lamont, now the Lamont Doherty Earth Observatory, and the Library of Congress, which recognized her as one of the 4 greatest cartographers of the 20th century. Marie Tharp laid the groundwork for every modern effort to map the floors of our planet's last frontier. Just as her hand-drawn maps revealed Earth's unseen landscape, today's autonomous vessels are mapping vast underwater territories with stupefying speed and accuracy, as we'll cover shortly. In this new era of exploration, her legacy is both a touchstone and a springboard for what's to come. So, thanks, Marie, for mapping what's under us and ahead of us. Hit those show notes for some quick caps on drone LiDAR mapping 1,000 acres of U.S. Air Force Base forest, 3D scanning's 2025 predicted trends, BIM going BAM in Japanese construction, Parkinson's treatment through AR, the percentage of architects using AI, and Finland's geospatial data via self-driving cars. And with that, recap number 1, Abyss Autonomy, uncrewed vessels, geospatial collaboration, and Florida seafloor mapping. Shakespeare's The Tempest told us that full fathom 5, thy father lies, aka some dude's dad shipwrecked and was on the seafloor or something. Whew. Good thing that's had centuries to be resolved, because now we've got data in the same place to get to. Lots of it, in the name of the Florida Seafloor Mapping Initiative. The best part? A massive team-up is collecting it, all without getting wet. The mission co-captains are Wolpert, boasting their renowned LiDAR and sonar bathymetry and hydrographic survey acumen, and Chance Maritime, whose uncrewed ocean drones' power and endurance are like if a linebacker and marathoner had a kid with fins. According to Wolpert's own press release, it comes at the request of the Florida Department of Environmental Protection, seeking coastal resilience and hurricane and flood inundation mitigation. So Wolpert enlisted Chance Maritime to mobilize its mission-capable 29, a 29-foot uncrewed survey vessel, enabling the firms to monitor vessel operations and data collection remotely. Wolpert coordinated staff across time zones to monitor data collection 24/7 in consecutive shifts, while Chance Maritime provided continuous Florida-based vessel monitoring. According to Chance CTO Michael Scherer, the team maintained constant communication during shift handovers, allowing remote equipment monitoring without seasickness. The ability to respond to vessel hails remotely and avoid shore returns for crew changes or brief weather events dramatically improved efficiency. Wolpert VP and Maritime Market Director Dave Neff said this streamlined approach enabled Wolpert's hydrography team to mobilize to other project locations, expanding efficiencies to outside the initial project. Quote, "There's a lot of coastal mapping, dredge, spoil surveys, and more that needs to be done to support navigation safety, national security, coastal resilience, disaster mitigation, etc., Neff said. We took this novel approach by combining our advancing resources and technologies with those of Chance Maritime, and it proved successful for all involved. We're excited to build in this technology partnership to advance our maritime efficiencies while still collecting and delivering the highest quality geospatial data. Moral of the story, in the depths of the sea, don't take unnecessary risks when you can take a chance." Recap number 2. Can construction tech adoption really be as easy as 3 steps? Well, like Marky Wahlberg says in The Departed, maybe, maybe not. The next line, well, if you know, you know. But RDO Equipment's Dennis Howard sure thinks so, based on his decades in construction equipment, wide net of contractor contacts, and recent contribution to 4 Construction Pros. The piece rejects the common but slightly fictitious pursuit of one total, instant job site tech solution for something that resembles great barbecue, low and slow and deliberate strategizing, or at least doing so in stages, 3 to be precise. Through a lens of infrastructure, agriculture, and transportation, the first stage laid out by Howard is understanding, developing a true comprehension, not a feeling. He cites OEMs like John Deere that as far back as 2000 worked tirelessly to grasp telematics, fleet management software, and other job site tech, and what that now yields them, especially in complementing survey equipment. Howard's Stage 2 was adjustment. After obsessive reviewing of data and performance, it is where real transformation happens, where we can refine workflows, break down silos, and ensure that teams properly use the data they collect to drive smarter decisions. Howard relays use cases of nimble preventative maintenance and road building crews adjusting their work based on the real-time grading GPS data points derived from LiDAR-based survey equipment. Companies that embrace this phase don't just adopt tech, they maximize its impact, setting the stage for the long-term success derived from Stage 3, integration, specifically software apps. It's where technology stops being an add-on and becomes second nature. At this stage, new tools are fully woven into daily operations, making workflows smoother and decisions faster. The key here is consistency, reinforcing best practices, ensuring data flows seamlessly across systems, and keeping everyone aligned, as evidenced by Howard's telling of Department of Transportation quality inspectors reviewing a digital twin generated by a company to collectively discuss optimal compaction, that's mechanically compressing asphalt to remove air and increase density. So all in all, if you're sufficiently thoughtful, you can keep your ConTech adoption plans thin while your roads and infrastructure are kept thick. Recap number 3, LiDAR and AI, giving pedestrians, cyclists, and engineers the light of way. Missouri is known as the Show Me State, and it might have to rebrand as the Save Me State on account of how its innovation is protecting pedestrians, sharpening driver awareness, reducing accidents, and illuminating behavior in and around work zones. It's from the work of engineering researchers at the University of Missouri, anchored by Associate Professor Ya Adu-Gayamfi and graduate student Lin Ling Zhang. Per a UMIS press release, their LiDAR and AI-based method is a new way to interpret how pedestrians, cyclists, and vehicles interact, with particular focus at stoplights and work zones. The 3D proficiency allows experts to measure the speeds of bikes, cars, and humans. So the crew set up a joint camera and LiDAR system at an intersection to monitor traffic flow. Also, by applying a method called point cloud completion, they improved the visibility of pedestrians and other objects over existing methods. Adu-Gayamfi explains, quote, "By having a better understanding of how pedestrians and cyclists interact on the roads, this study will help us design advanced systems that will allow vehicles to better understand and avoid other road users. This is important, especially as autonomous vehicles become more common. Self-drive? We thrive. Let's go, Professor! He continues. This approach would require working with car manufacturers to build the technology into vehicles. In fact, some cars already connect with traffic systems using networks like Cellular Vehicle to Everything, that's CV2X. This data could be used in other ways to improve transportation, like helping experts decide how long pedestrians need a green light to cross safely. It could also track cars entering work zones, catching speeding or distracted drivers. Plus, it can spot pavement problems, such as the depth of potholes. And we'll see if it'll be able to scold texters while driving. As it stands, though, there are 3 obstacles preventing this tech from widespread use: data processing, power supply stability, and inclement weather operation, each of which are continuously being hacked away at by the UMIS Engineering Safety Squad. Salute. Recap number 4. Exam, cleaning, x-ray, photogrammetry? Regardless of industry, digital transformation has mostly manifested by word of mouth. Now, it's the word in mouth. As dentistry today details, for decades, dentists had no choice but to opt for traditional impressions to model the oral cavity, relying on physical materials to capture teeth, soft tissue, and implants. But these methods often require retakes, causing discomfort, contamination, and added costs. Prone to deformation and inaccuracies, they struggle to deliver the precision complex implant cases demand. Well, demand meets supply in the form of photogrammetry. Now, photogrammetry at its core is not brand new to dentistry. For nearly 2 decades, 2D images have been augmented with 3D images thanks to cone beam computed tomography, CBCT, and interactive treatment planning software. But IPG, or intraoral photogrammetry, is new to dentistry, uniting the precision of photogrammetry with the convenience of IOS, that's intraoral scanning, which has forever been a supplemental requirement in order to capture surrounding soft tissue. In short, IPG allows clinicians to capture both implant positions and the surrounding tissue in a single scan without that need for separate images from 2 different capture devices or manual data merging. The system utilizes coded intraoral markers to accurately capture the spatial relationships between implants within the oral cavity. The resulting model can be directly transferred into CAD or CAM software for rapid design of implants and restorations. Some reports even say they can be done in less time than you'll spend waiting in the lobby for your appointment. Ladies, gents, the time is now for your AEC Error of the Week. In the space between design and execution lies a profound truth. Our greatest engineering disasters are rarely failures of materials, but failures of diligence, communication, humility. This week, we explore how seemingly minor altered details cascaded into catastrophe. In 1981, Kansas City's Hyatt Regency Hotel stood as a monument to engineering and architectural prowess. Its soaring atrium, adorned with suspended walkways, promised a spectacle of design and functionality. Little did anyone know that it was about to become one of the most tragic engineering failures in American history. 7:05 p.m., July 17th. The hotel's atrium buzzed with the energy of 1,600 souls gathered for a lively tea dance. Some revelers seeking a better vantage point ascended to the suspended walkways that crisscrossed the atrium. Suddenly, a series of ominous sounds pierced through the festivities. Popping noises, followed by a loud crack. The 4th floor walkway, bearing the weight of dozens of partygoers, trembled and then plummeted onto the 2nd floor walkway below. The combined mass of steel, concrete, and bodies then crashed onto the crowded lobby floor, transforming the once elegant atrium into a scene of unimaginable horror. At the heart of the disaster lay a fateful design change. The original plan called for a single set of rods to support both walkways, running from the ceiling through the 4th floor and down to the 2nd. However, in a misguided attempt at assembly simplification, separate rods were used for each walkway, with the 2nd floor walkway suspended from the 4th. This doubled the load on the 4th floor connections, pushing them far beyond their capacity. Additionally, the longitudinal welds of the box beams meant to bear the weight of the walkways and their occupants were simply not strong enough. But the tragedy of the Hyatt Regency walkway collapse goes beyond mere technical failures. It underscores the consequences of assumptions, miscommunication, abdication of responsibility. Engineers assured architects that details had been checked when they had not been. Workers noticed irregularities but remained silent, deferring to the supposed expertise of others. In the aftermath, the toll of this cascade of errors became painfully clear. $140 million in damages, 114 lives lost, over 200 injured, and countless more forever changed. The Hyatt Regency collapse remains a stark reminder of how critical precision is in engineering, and how technology ameliorates our human foibles, oversight, miscommunication, and sometimes plain lethargy. Those applied in 1981 and will still apply somewhere in 2081. Modern reality capture technologies can mitigate or even prevent such catastrophic downfalls through keen insight into structural integrity. That last-minute change to the suspension rod design, made during fabrication, it bypassed a full structural analysis. With BIM and digital twin tech, engineers could have simulated the effect of the design change before approval. Load distribution modeling would have exposed that fatal flaw, demonstrating that the lower walkway's connections were never meant to carry such a burden. Immaculate 3D models born of photogrammetry or laser scanning could have evaluated the box beams, detected deviations from the original design, and flagged the critical difference in suspension rod placement. Outside what was once the Hyatt Regency, a memorial stands, a sculpture evoking a couple dancing, frozen in time, forever unaware of what was coming. It is a reminder of the lives that should have never been lost, of a night that should have only been filled with music, and of a tragedy that should have never been written into history. And given today's AEC innovations, the question is no longer whether we can catch mistakes just like it before they become catastrophes. The question is whether we will choose to. Enjoy your day, recappers. Check out the show notes for those quick caps and sources. Like and subscribe to advance innovation while always knowing what's cappening, who's driving it, and the history behind it.